Hey, and welcome to gambling. As much as I would love to be rich and famous and own a neon pink Bugatti, I kind of suck at it. All I know is that I definitely don't want to spend time to properly learn the game strategy, so I'll just spend a month to build an AI that plays it for me. When I started, I was like, oh, this is easy. I'll just put that there, this here, and boom, I have a receding hairline. It turns out that the logic for four AIs interacting and learning from the same complex environment kind of sucks to code. But anyways, let's talk about the game. So, we're going to be playing BlackJack, or commonly known as 21, and we're going to see if we can beat the dealer. The game is the dealer versus the player, and the house always wins. Mostly because the player is a bum. The dealer gets two cards, one is going to be face down, and the player will get two as well, but his both will be face up. The player will go first. They can either hit to get more cards, or they could stay with the card they have. Face cards are worth 10 points, and aces could be equal to 1 or 13 based on what the player needs. So let's say our hypothetical player has these cards. He would have an 11 or a 23. But the purpose of the game is to get as close to his 21 as possible without going over. If you go over 21, you would immediately lose and you surrender your bet to the dealer. So we choose 11 and hit or draw another card. We get a 5 and decide it's too risky to get another card, so we stay or do nothing. Now it's our dealer's turn. He flips open his second cards, and he has the additional advantage of seeing the player's cards and his own. He is then presented with the same opportunities to hit or to stand. Clearly he goes for a hit. He then has higher than the player, so he wins the game. He would take the player's entire bet. If the dealer busts or is lower than the player would get back double the money he put in. So, our player does also have some advantages. Blackjack is an automatic win. A blackjack is when you have an ace with a 10 value card. You can double down your bet, your initial bet, after the first two cards, but then you can only get one extra card afterwards and you just have to play it out. Split is when you play your hand as two cards. You can only split when you have two cards of the same ranking, like 2 7s or 2 5s. So, how are we going to solve it? Well, we're going to build this AI using reinforcement learning, specifically deep Q learning, but we'll go deeper on that in a bit. Let's start building the game. Okay, so our AI needs an environment to interact with. We can use Pygame to set up our poker table and all the players. Well, we're going to have 4 players, including the dealer. Basically, if I'm able to play the game through the keyboard inputs, then we can later substitute inputs coming in from the decisions our AI would make to play the game. I had coded another Pygame application before, so a lot was from that game, but you know, it works. After maybe an hour, we had our first instance going. I did some resizing to the cards and screen to get the best playing environment, but I think it turned out pretty well. Each player's positions are tracked in the game, so we need to write a function that can determine where the cards need to be placed according to that player. Nope. Okay, we're getting there. Where did player 1's card go? Let's go first try. Okay, since we can't have all the cards be aces, we have to add some more cards to our mix, and then simulate the real properties of a deck. An addition we need to make is to make sure that we can only see one of the dealer's cards. Of course, we need to actually play the game. Hold please. It works, I'm so happy. That was painful. You can't see, but on my second monitor I have a console just telling me which player is going and what my options are, and I'm typing in either to hit or to stand or to double. That hidden card just kind of goes away, and it requires a whole 30 brain cells that I do not currently have to fix, so we're just going to be good programmers and ignore it. As long as I tell the AI just to look at the second card, it really doesn't matter too much. There are no win conditions, technically, so it kind of just breaks at the end, but baby steps, okay? So, we'll be solving this problem through reinforcement learning. The AI will initially randomly pick an option, and this option will cause the environment to change in some way. After it has interacted and changed the environment, the new environment will return to the AI a couple of things: the reward, the next state, and whether or not the AI has completed the task or round at hand. Before I decided on this project, I had no clue what I just said, so I made a sample game that was simpler and made the concept a little clearer. Allow me to explain. We're going to make a 5x5 map, and we're going to make the 8 the character player. Don't ask me why, I don't even know. And our end goal will be 2. The player is trying to get to this 2. Again, I just pulled it out of nowhere. We will randomize the ones throughout the board, Zeros represent open spaces, but for clarity, I will just not show these. We can implement a depth-first algorithm to make sure no matter what board is created, there is at least one path that connects to the goal. It basically looks like this ugly array in real life, but before we go any further, we need to discuss something called a state. A state is basically a numerical statement of the current position the player is in. So let's try to describe our character right now using states. The way we describe the state of the player is shown. Typically, the more descriptive you are, the better the player will come out, but it comes with the computational costs. Currently, the player is like this. With the borders of the map acting as walls, they will be seen as ones. So, our computer would get this number corresponding to its state. Just so you know how computationally heavy this becomes for such a simple game, it's 5 possible row indexes, 5 possible column indexes, 3 possible things to its left, a 1, 0, or 2, and to its right, and above it, and below, leading to about 2,025 different states. And that number is comparatively nothing to our poker game. It's an upwards of almost 100,000. The AI will be sent this state and it will process these as inputs to a neural network to return the best action. Oh, but wait, how does it learn the best action? Asked your tiny brain. That's the magic of it. At first, its guess is as good as random. Let's say it randomly tells the game to move left. The action is taken by the game and a reward is given. For the simple game, every time it moves, it is given a reward of -1, and when it moves onto the reward square, it's given the reward of 10. Each reward will basically tell the AI whether or not it's doing a good job, so that it can learn as it explores the map. Now think why this reward system makes sense. This incentivizes that the AI takes the most efficient path, as it will get the most total reward from taking the least amount of time steps. If an AI takes a lengthy path with many time steps, its total reward does not end up so hot, versus an efficient path which ends up with a positive reward. While there's some more that goes into this concept, there is just one last thing I want to bring up. Voila, the math. This requires a lot of explaining, and animating this is cramping my finger, but the basic idea of this equation is that it links future reward to current action. This way, we can link together multiple actions to not just do what's good for the AI in the moment, but also in the future as well. It's a really cool concept, and if you want me to make a video explaining all of this with more depth, I would love to. Okay, so let's get started. So first we had to make the game. So we import all the things needed for the game, like NumPy, random. This is just to clear the output, some other things. Here's a short description of the game that we've already talked about. And then so then we start building the game. So let's run this function, or this class. Basically, it's going to create the game. It has a couple of things. The game, it builds the space, the map. It's going to be able to move right, left. Here, let me run it. Move left, right, down. You can check the winning condition. You can also reset the game. You can get the state that the current player is in. And then step will allow you to call from an external state right here. We'll put an input in and he'll call the step function, allowing this to occur. So let's see. This is the output. The game shows this little grid right here. And we have, of course, 4 options to move up, right, down, left. So we can move, let's go right. And it gives us the reward. Because we took a turn, it's going to be a -1 reward. The game is not done yet, and here's the next state array. And then we're going to move right again. Let's move down, down, right, right, and then, so when we get to the final function, it gives us a reward of 9. There's a -1 for the move, and then +10 for achieving the goal. It tells us the game is done, and then, of course, gives us the state. So that basically is the game function. Then we can import all the needed libraries for machine learning. And then here is the DQN, or Deep Neural Network player, or model. It will learn as we keep playing. So we can start it and let it train for a little bit. For BlackJack, we have a slight challenge, and by slight, I mean incredibly annoying. First, we have to simultaneously train 4 independent AIs in the same environment. Then we also have 2 different types of AIs as well. The player will only have their cards and one of the dealer's cards as inputs. They also only have to beat the dealer and have 3 options: to hit, stand, and double down. While the dealer will have his cards and the cards of all the other AIs as its inputs. But he will not be able to double down and has to try to make more money than losing based on the number of players at the table. Finally, the reward for getting close to 21 versus the reward for money gained from the game should be balanced perfectly so that the AI knows winning matters more than getting closer to 21, but it also understands how to win and what it needs to do. Okay, please hold. Yeah, see that transition? Yeah, it's been a week with no sleep. I think I ran into more bugs than minutes I slept. But it's done. It's done. Okay, a linear reduced reward was given to the player for getting close to 21, and once the round was over, the players were rewarded based on the money they earned. I can't even begin to describe the self-discovery journey I embarked on while making the AIs interact with each other, but they play nice now. Alright, let's get to training. Alright, now that it's finished testing, this was only around 100 episodes, we're going to see if we can put the AI to the test and play a real game. Now the money will actually be tracked as it's lost and won, and we'll be able to get some results of, the money that each player lost, gained, and the distribution of moves they made. So let's see. Okay, so we trained the AI for about 100 episodes, and you can see on the screen the dealer rewards and the player rewards. Now it might look like nothing, but that's because it is. It kind of has to be around 0. Why? Because that means they're both training together. Remember, they're training against each other. They're adversaries. Adversaries? They're against each other. So the dealer, as it increases or gets better, then the player gets better to counteract that. And as the player gets better, the dealer will also try to counteract that by it getting better, meaning it stays around 0, which is kind of correct. Then we go to the next one, which is even cooler. This is the player profits and the dealer profits. So as the game progresses over the 100, the dealer sucked. The dealer had no clue how to play whatsoever. And what's even cooler is that all the players kind of stayed around equal, with player 2 going a little ahead. But of course, it's only been 100 rounds, so it really hasn't had time to learn anything yet. And it sucks. Okay, so let's go to 1,000 episodes. After 1,000 episodes, things get very interesting. So this time now the dealer is winning, but you can see the dealer has weird spikes where it increases a lot at once and then suddenly drops back down, increases, drops. However, player 1 has a steady rise. So player 1 obviously was doing something right, while player 2 and player 3 just dropped to 950. But still, this is much, much, much better than what the earlier one was. And you can see the difference here where the dealer is actually making logical decisions and the players are fighting back. So this is a really cool progression, but we can check even closer. We can look at the player 1 versus the dealer moves, and player 1 has an interesting concept because player 1 was the winner. It never doubled down, so maybe doubling isn't the best option, but it still hasn't learned fully enough for us to really get that. But it didn't ever double down, and yeah, it seemed to do pretty well. Okay, so how about 5,000 episodes? Well, after 5,000 episodes, things get really cool. The dealer wins without anything. So the dealer has learned a strategy to play where it cannot lose, and it doesn't. It constantly is winning. So if you ever want to be a dealer, use this AI and boom, you will make money. Now player 1, 2, and 3 all decline, except player 2, which slightly increases, and ever so slightly it wins. And you can see very interestingly in the beginning,
They all play very well, meaning they don't fall too far below 1,000 and they're fighting constantly. But something happens around round 30 that causes them to diverge. Player 1 completely sinks it, while player 2 is able to retain its earnings, and player 3 slightly declines it, while the dealer skyrockets. Let's compare these graphs, and again you can see very clearly that the dealer is doing so much better in this round, and the players somehow can't compete. So what did the dealer do correctly? Well, if we look at the graphs, the dealer seemed to stand more than they hit. Most of the time, by standing, the dealer was able to make enough money. Player 1 and Player 2 are a very interesting case. Basically, Player 1 was the loser of our game, and they seemed to double more than they did stand. And they hit the most, of course. Player 2, on the other hand, still hit the most, but this time they stood or did nothing more than they did a double hit. So, very interesting to see that maybe doubling only works in very specific scenarios, and we should be wary when we do that. So, good thing to learn. Alrighty, let's switch to playing. Okay, so I think the dealer has 20. I'm gonna, of course, hit. I only have 7. That puts me at 11. I have to hit. Okay, I think. I lost that round. Damn it. Okay, 19. I can go for a hit. So actually, let's double down. Why not? Because there's a good chance we'll be close. Yes, maybe. Oh yes. All right, made that money. Good. I'm just watching like the money market go up and down. I have 16. I shouldn't be able to see both of the dealer's cards, but you know, I'll just pretend I only know he has a 10. 16 I would technically stand, but he beats me there. Yeah. Wow. Jesus, dealer's actually good. I'm gonna hit because this could be a 1 or a 13. So okay, so now it becomes a 14. Ugh. Hit. Nope, I busted. Okay. Jesus, this dealer's just taking my money. So he has a 2. Oh, I shouldn't say that, but it's okay. Let's go. Oh yeah, wait. What am I saying? Stand, of course. Please, 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 please. Okay, I'm at 1,000. Okay, 10 I have to hit. 13 I have to hit. And I busted. God, this game sucks. How is he at 100? All of us are broke. Okay, player 1 is doing okay. I'm kind of to the left side here, but player 1 is doing incredible. I'm gonna hit and stand. Oh my god, I hit 21. Let's go. Let's double down. I haven't tried that. Come on, come on. Oh, I lost it. Double down again. Please, 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 please. Yes, yes. Okay, that's the game. Cool. Alrighty, so clearly our dealer knows what he's doing. But this time, I gave him slightly a run for his money on player 2. But it's a good competition, so meaning this dealer knows what he's doing. He can understand human inputs, and he can understand how to play each card the best possible. And I think that's really, really dope. I think if I played more, we'd definitely be able to see a branch. I would lose all my money, I'm sure. It's beginner's luck. But I'm excited to know that this dealer actually can be playable and would give you a pretty good game and a run for your money. So. Hey, before we wrap up, I just wanted to say thank you guys for watching. I mean, seriously, if you made it to this point of the video, you've been through a lot. And yeah, I really wanted to try something new, make a video out there, and I hope it was enjoyable. I hope it was interesting. If there was anything I could do, anything I could make, I would love to know. But yeah, thank you for being there, and take care. See you soon.